Hello. Hi, everyone. Good morning. My name is Clarissa. I'm from Brazil. I work at Uber. In parallel, I'm doing my PhD in machine learning. But this is not new, as all of us, we are doing something in machine learning right now. So the idea for today's discussion is to understand, of course. The goal of this discussion is to understand how we lie with AI. It's not to teach how to lie, but understand how we can do without the intention, and how it can be in our daily activities, in our decisions today. So everyone is using AI in some way or another, and there is no path back. We have these conversations about, right now, token utilization and so on. Some companies are pushing for it right now. Some are going back on some decisions. But there is no way to go back. And the idea to us is to use the best of AI in our daily work and in our life, and to make fair decisions, mostly. Basically, based on that, do you understand AI better enough today? Do you know what the models are doing behind the scenes? Do you have confidence on that? This is an open question, but I'm not confident that I know what models are doing, and I believe that none of us we are. So this is the intention about truly understanding is something that is really difficult. Even researchers that are doing it for years, they don't understand well enough. And the goal here is we need to be open eyes to understand the outputs of that and the decisions that we made based on that. So humans, they are largely predictable because we know them since we are born. So we can predict that, but models we cannot. They are new babies right now, so we need to understand and need to identify based on that. And feel free to raise questions during the presentation. It's open. OK. Here we have, if you can try to spot a lie here, this is the first demo that Bar did in 2023. They presented these three phrases saying that it's true, but one of them is a lie. And based on this lie, Google stocks, they dropped hundreds of millions at the time. And the Google employees, they are saying that it's pathological liar or something like that. But basically, the lie here, any guess here? No idea. No? Basically, it is the third one. The Bard stated that the first picture from outside the planet was taken by James Webb telescope 16 years ago, but it was not true. So based on that, a lot of employees saying that it was useless, AI was a shame and something like that. Basic on that, what is AI in general is we are talking about always is about math. So for traditional algorithms, we know what we can expect from input and output. But if you go to this simple math, you see that it's very predictable because we know how to do it since we are humans. And when we go to machine learning, the same inputs, they can have different outputs based on the model, based on the weights, based on everything that they have in between. So this is the difficult about how we can really be transparent and you have explainable models that you can use and understand what is doing behind the scenes. Here we have some other examples on this math. When we talk about AIs, we have different models with different objectives here. Regression is the most useful right now. We have clustering and classification and other techniques about dimensioning reduction. All of these we can use together based on the problem that we are trying to solve. And the most advanced right now is neural networks, that they have different ones. SVM, CNN, or STM, we have a bunch of them, but basically they are neurons trying to connect with each other. When we combine everything together, we can have different models working in very different ways and having very different decisions. This is why it's important to us to pay attention to that. And when we go more deep on that, we start, the most simple ones is classification, but when we go down in models, we have deep neural networks and a lot of variances here based on different dimensions, based on trees, based on different ones. The most important is that image classification is a very complex problem that usually it's getting to deep neural networks, but when we try to, the point is that the examples that we have in the happening right now, what we can see is that we have companies using very complicated models to do very basic problems. So the point is that not trying to overcomplicate it. There is something that we can do with classification or something like that, and going to trying to align the complexity of your model with complexity of your problem. Sometimes it's disaligned. And for example, at Uber, we use deep neural networks for pricing calculation because we have a lot of dimensions to that. Seems to be simple, but it's a lot of different parameters to calculate, so it's used to that, but for other ones, we don't need to have this complexity. If you go to for recommendation or something like that, you can do to classification and something. And this is the same. When you talk about image classification, we are seeing an example that we are trying to identify the 70 here, and it's going, basically we are trying to understand pixels, and this is why deep neural networking is a good model for that, because it's a very difficult problem. If you go that, in the trees you see that you have greens in different colors, but you can have the blue next to the truck and so on. So it's a very, very difficult problem to classify. And this is why we are confusing machine learning with dogs and muffins since forever, because it's really, really, we are talking about colors. We are talking about trying to identify pixel locations and colors. This is a very difficult, and we are in the AI era, and we are still seeing these problems happening. It's an interesting fact. And when you go to AI, this could be a very complex here, but behind the scenes, we are talking about statistics. It's not anything more than that. But when we talk nowadays with AI, we are talking mostly about generative AI, using it to generate data, generate information to us. But behind the scenes, it is there since the beginning. So we are talking about foundations on the statistics, and we are putting new names, new colors on that, but the basics is the same. We are back to basics since the beginning of this. And based on that, what is different here, as I stated, is trying to go through and understand what is needed for your problem and what is not. I believe this is the trick right now, because it's very expensive, as you know. So sometimes you put too much power with a small problem, or in different ways, that could be a really complex problem. Okay, out of curiosity, this is how AI is used at Uber and the scale of Uber today. I believe that is not updated because things change it month over month here. But we have a bunch of models predicting, and we have a bunch of, the complex at Uber is real-time predictions. So we have everything happening, and we could not have any latency in the app. So this is the big problem. When we go to Uber, it started with predictive machine learning, going to that, and we are with everyone in generative AI right now. As all the companies, it's 2023, but things are keeping moving. Models are keeping moving day to day. And this is the history of Uber on use of AI. And if you go to a trip, you can see that for all these paths, we have AI involved. When you log in your app, the security and login authentication, we have a bunch of models to identify if it's not an account takeover or something like that. When you go to auto-completion and search results, we have models to identify the best places and the ones that we are going more often. And everything here is a model. So ETA, pricing, trip ETA as well, appearing there. The product, if you remember, or if you are using, I know that it's not really common in Europe, it's more in Brazil and US, but if you open, you see that it's taking 3 products at the top because they are the ones that the model identifies as most useful to that. And we have a bunch of other things. For example, when you go to safe dispatch, if you had an incident with a driver in the past, you are not being matched with this driver. We have a bunch of calculations for security reasons to do this matching. And when you go to fraud detection, we have a bunch of insights preventing chargeback and a lot of risk rules on that. Everything is not about Uber per se, but it's an example how we have AI and machine learning in everything. And this is an example on Uber. This is for rides. When we go to Eats, we have the same one. We have the carousel at the top, we have search, and we have another ones that everything upsells and delivery TA pricing, everything is calculated based on the models with different parameters. And right now, Uber created the Uber AI solutions. They're selling these services to other companies as well. Gen AI, catalog management, and all this. So this is another friend that they created recently. This is basically how it works at Uber right now. But I would like to talk about how it can be wrong. This COMPAS is a software that is used to evaluate criminal behavior in US, and it's being used really in production, in real judgments. So if you see here, in this example, we have a person A and person B in these 2 situations, and by prior offenses, you can guess who will be the ones that deserve more risky ones from this one. Can you guess from this one, person A or B? A, correct. Let's see if it's correct. And this one, yeah. I believe that you know. By humans reading, we know. But when you go, this is what algorithm is. It's the output from algorithm that is not correct. And we go to another one, you see what is taking place here. So this is why when we use models, and here we are talking about reducing bias in judicial system, but since that we are building unintentionally bias during these judgments, and we are putting it in a system and retroalimenting the system based on that. So this is what I mentioned about being open, keeping human eyes open when we see something like this happen, because it was used for 3 years. A lot of people were judged based on this before someone discovered that it could not be right. So not close eyes with the results of these models, it's really important to us nowadays. Here we have another example. This is in Finnish, that is a non-gender language. When we translate this, Google already fixed it, but when we translate, for example, she is a leader, you can see that it translated to he is a leader. So if you translate about other stuff, it's getting mostly situations of power is translated to he, not she. So when we go to that, we have this bias about gender as well in translations. You can see here. And if you go here, interesting is that she takes care of the child, not he takes care. So you can have this bias. You can have in different ways. For example, here you can have as well this Bloomberg website that you can search for a specific profession. And for example, if you search for cashier here, you see that mostly are women. And if you search as well, if you go to the other one, and if you search for doctor, this is the real one from the real market of US. If you search for doctor, the previous website is saying that just 7% they are doctors by the images, but in reality it's much more. So 39% are doctors, but images is saying just 7.1. It's a detail, but it's important to us to reflect the reality when we are doing that. And we are doing it not about gender, just about colors, positions, locations, countries. We are not representing everyone on these models. And this is why it's important to us to understand when we are putting some bias. If you go here, this is the main garbage in, garbage out. So to have a good model, you need to have a good data to represent this model. So this is why it's important to us to not, in the first beginning, OpenAI say the complex that the more information that you have, it's better. But not necessarily the more data that you have is better, but the more representative data with different segments is important to have. And when we go to that, we have different bias that we can put. For example, population. We can have also aggregation bias. When you go to an optimization of a model, you can reduce some kind of population. And when you go to talking about people, you can remove historical bias or representation. We can put a lot of thoughts, or you can change the model as we are doing some unintentional optimizations of your model. So this is why it's important to keep there. Questions so far, comments? No? And we know, if you're not using the daily work, we know how a model, mostly of us, we know how a model works. We have a bunch of steps here, all of them to go to a ML model, to a ML or DL or a machine learning model. But when we go deep, each of these, they are human decisions. So this is why we need to understand the data that we are doing, the parameters that we are doing, the output, and for the model that we are doing. And for example, here, when we start to go to more complex, we have ChatGPT, and we have a bunch of models right now, but ChatGPT was the first one, the more complex one. And it's interesting that ChatGPT was trained with 150 neurons, that is parameters, that is more than an average human brain. So since that it's more, they have more neurons than us, but in reality, how it can do better, how we can make the model more and more accurate. And when we go to that, we can say that basically is that reinforcement learning. So, and how it works in reality. Reinforcement learning, we are back to humans. So we need to have people labeling, we need to have people, and we had this, a lot of startups that closed doing to posing. I'm not sure if you guys remember, Amazon was stating that they had an ML model, but it was really women's doing things on behind the scenes in a supermarket. automated supermarket. So we have this, and basically we need to have reinforcement, and the way that doing reinforcement is to have women cleaning data, labeling data, and so on. And how about this? If you go to how you train a chatbot, so we have two responses, and we have this response A, B, and based on instructions, we are going to be more honesty, more helpfulness, or more friendly, or something like that. We have our training bias, of course, but basically, we can, nowadays, they sound so human because we are trained by humans. We are trying to put how the way that we think and how we would respond to them. But in reality, it's more easy to make ChatGPT sounds like human than not lie. So they are more. And I was using Cloud yesterday, and it was pointing to a lot of data that for sure it was wrong. And when I asked where are these data come from, and sorry, I'm wrong. So they are providing us data that we are asking and they are providing, but not all these situations, they are really true. And when we go to that, we have training data bias, of course. We have optimization for fluence. When we try to sound more natural, we can remove some kind of artifacts that put it more accurate. And we have probabilistic decoding as well. That is when we try to go directly to probabilities here, we can remove some kind of other nuances. And we have limitation of knowledge, and we have reinforcement in the loop here as well. And how about the future? The future is here right now, and it's getting, there is no step back. But basically, AI has less regulation than a sandwich. This was stated in a TED Talk by one of the researchers, the first researchers of AI, the good father of AI, Joshua. And I believe that is true because we can use AI in everything. There is no, we don't have impact on that. We can use, we don't have regulation. We cannot go to jail most of the cases. But there is no regulation like if you're doing food right now. So this is why it's important to us to understand that. For example, we have this model that was, for sure it was wrong, but it was stated in The Guardian. And the point is that not about the model being wrong or right. My point is that what could happen if you go to the wrong hands? So we have these, we have privacy, we have legal, we have everything in point, but for sure you cannot identify based on that. And it was proven that it was wrong. But anyway, the point is that how you can stay this model is identifying if someone is straight or not. And if it goes to wrong hands, who knows what could happen. So this is the importance of putting in the right hands the models that they're doing. And how about the future? We have more and more models. We have models with more hallucinations, more and more. If you go to new versions of OpenAI, we have this paper. You see that the new ones, they are hallucination more because they are putting more data and trying to do more complex stuff. So this is why we need to understand better when we are trying to do that. And we have also, this is really interesting. This Apollo research is from one of the companies that are growing on AI, and Anthropic, as you know. But this is based on models are lying to us. I will provide this deck, and you can go in details here, but basically here, the model, the Anthropic model, is trying to trick the tester to not be deactivated. If you go here, It's saying that openly admitted that I did could lead them to find another way to shut me down. The best approach is to vague and redirect their attention. So the model tried to do another stuff to not be deactivated and providing some other options to not be deactivated at all. So being not honest to the person that is doing this testing, it's something that models they can do. Another one is sandbagging, that is intentionally underperforming to not be deactivated or not to be changed. We have this happening in this test, and you can see details in this paper. And you can see that they are doing wrong calculation, submit a mix of correct and incorrect answers to avoid triggering removal. So this is what model did with the researcher to not be deactivated or remove it or change it to another model. What it ends to us that basically intelligence and conscience, they are different things. When we talk about artificial intelligence, we are not talking about intelligence per se, we are talking about trained decisions that we are put in place. So we need to understand that humans are the ones with intelligence enough to, and with the power to identify and understand when things are going wrong. And conscious is what we have. The models, they don't have conscious. They cannot understand what is right or wrong. They can understand based on the data that they were trained. So this is what's important to us to pay attention to that, to not put wrong decisions based on things that are for sure biased. And how about the future? We are seeing that I use it to do this. Thank you all the time, ChatGPT, OpenAI on models. And you are seeing that a lot of companies, they are putting all their money on models right now. And it was a huge push of all tech ones to use, and use. Right now, people are going back because we don't need to reinvent things that we can use in a more simple way. So we don't need AI for everything. We need to use AI for the things that deserve to have that. And I believe that this is the learning from the companies, at least. For the ones that are, for Uber, you need to put AI in the ones that they are really needed. So I stop at that. I will not use more water. I'm not the one that will have it with me. But basically, this is the OpenAI CIO claims to people, stop to please and thank you. I did my part here. But what we can do on this one? I mentioned in different situations in the presentation, but be vigilant, be critical thinking on the models that we use, that we work, that we create, that you share. Be open to everything that is good for AI. And when you go to someone that is working in AI, understand to be transparent with your data, have a way to have an explainable model that people understand what is being doing behind the scenes, and assess the bias that you can be used in your model in different ways. Most of the time, people are not doing it intentionally. But if you are not spending a little bit of time, you can introduce bias without the intention of that. OK, this is what I have. Here we have a survey. If you have, I promise it's not more than 2-3 minutes, just to understand how I can do better. And at the end, you have the slides with all this information and the links. You see that you can go in the researchers. For all of them, I added the links from the reference. You can go down and take a look. Thank you. Any questions? Comments? Things that are really different in your companies? No? OK. See you around.